Welcome to our third lecture of the World on a Plate course. We have an action-packed day, so I want to go ahead and jump into our lectures today. So I'm obviously going to be speaking about the science of nutrition, and then we have Alanna Moshfegh from the USDA here to talk about using that information in the real world. This is a lecture that we did not have last year, and this is a new lecture that we wanted to add specifically to this year's course. We found that a lot of us are familiar with some of the terms I'm going to be talking about today, but maybe not with the details of the words and how to appropriately think about some of the nutrition principles and some of the nutrition words that I want you to think about. So what I'm going to do is walk you through a very brief overview. I'm calling it Nutrition 101 in my mind. But this could easily be a 3-credit year-long course just to do the topic justice. So I really am not going to be able to go into a lot of detail. But I'm hoping that some of you will be excited about this topic and that you'll choose to do this maybe as your assignment number 3, where you dig a little deeper into a topic. And I'm certainly happy in that respect to answer questions, to be a resource for you as you think more about some of these nutrition issues. But again, the goal today from my talk is just to give you a lay of the land, let you know a little bit about nutritional science, help you think a little bit about the terminology that we use so that you can use it appropriately when you're talking about all the other topics that we'll be talking about food-related in this quarter. So I'll start with a real basic definition. Obviously, nutrition is the act or the process of nourishing or being nourished. This is from the Merriam-Webster Dictionary. Some processes by which an animal, including humans or plants, take in and utilize food substances. Probably a topic that a definition that you're all familiar with. I do want to take a time just at the very beginning to talk about nutritionism. Those of us who are nutritional scientists have gotten a little bit of a bad rap from a certain journalist over the past couple of years. Michael Pollan I really do like. I really do appreciate all the work that he's done, and he's done fabulous things for getting the food message out. But he has kind of picked up on this term. Other people had used it before, but he uses it quite a bit in Omnivore's Dilemma and some other things that he's written about nutritionism or reductionism. Basically, the concept that we as nutritional scientists only care about the nutrients and the components of food and don't recognize food for what it is on the bigger picture. And a lot of times, we look at a single nutrient in a food, even though we know most foods have a wide complement of different nutrients. There's a lot of reasons for why that is the appearance that our field gets. First of all, we're all humans. And it's easier for us to think about things in the simplest, smallest terminology and think about the most basic details of things. So that's really where a lot of this came from. And we certainly have been very successful as a field, especially over the last 100 years, of being able to identify the nutrients that are responsible for deficiency diseases. And so that kind of perpetuated the reductionist idea. A lot of it also has to do with just our computational abilities. When prior to the computer age, we were doing a lot of things by hand. It's hard to think about elaborate statistical modeling. Now that we are getting into the era of big data, I think you're going to see less and less of this nutritionism or reductionism in the field of nutritional science. You'll see us looking a lot more at interactions between nutrients and what effect the entire foods have on health. I want to point out just one other benefit of thinking about things in nutritional terms, and that is that it can be a common ground politically to talk about food-related issues. We are in the process of revising the dietary guidelines right now. Dietary Guidelines 2015 are being developed by the Department of Health and Human Services and the USDA. And they are bringing nutritional scientists in from around the world to discuss, or from around the country to talk about the latest in nutritional science. But it's a government process, and it's also open to the public and open to comments from the general public. So we're also hearing from the food industry. It's easier for us as nutritionists to get on the same ground to talk about the nutrients in dairy products rather than to say that you shouldn't have any dairy products or you shouldn't have any meats. It allows us to find a common ground with some of the industry groups. However, I don't think there are any nutritional scientists out there that truly believe a food is only as good as whatever nutrient it is that we're studying in the food. We recognize that each individual food item has multiple nutrients, has multiple health benefits. Humans eat food. We don't eat individual nutrients unless you're taking dietary supplements. We also eat a variety of different foods several times a day, and you should do that. That's what we've shown over and over again is the best way to be healthy, is to get a variety of different foods. So I'm hoping I'm impressing upon you that the study of nutritional science, and especially the effect of nutrition on health, is actually a very, very complicated process, and many of us spend our entire careers trying to master it. And we still don't have all of the answers. And I think most of us appreciate that food is much more than just the nourishment aspect. There's definitely social, cultural, political, as I had mentioned, economic issues that are related to food, that if we as nutritionists ignored that, we'd never achieve our goals of helping people have a healthier lifestyle as a result of what we've learned from nutritional science. So I just wanted to say, in some regards, we acknowledge that we are reductionists at times. There's a reason for that, but we do think broadly and to a bigger picture. To that point, I like to use this Venn diagram to think about how nutrition fits into the bigger picture of everything that we're going to be talking about this semester in this course. Nutrients are a component of food, but they are not the entirety of food. They're, as I said, cultural, political, economic, social aspects of foods. One thing my colleagues in public health are starting to think about is even beyond food, there are issues that affect food choice and health in our communities. And many of us are starting to look at the food environment. How many grocery stores are there around a neighborhood? Do people actually have access to the types of foods they want, to the healthy foods they need? What's in the vending machines in a workplace? Are there farmers markets that are available to everyone who wants to have fresh fruits and vegetables? So in contrast to that reductionist view of nutritional scientists, I want to point out that we're really thinking really big as well and thinking big picture about foods. All right, so now I'm going to jump into some terminology and some things to think about. And I'm going to start off by talking about what we call the macronutrients. And one of the units that we're concerned about is energy that we get from food. And when we talk about energy in food, we're talking about calories. The calorie is actually, there's a scientific definition for it. It's the energy needed to increase the temperature of 1 gram of water by 1 degree Celsius. For those of you who really care about details, I think it's 14 degrees Celsius to 15 degrees Celsius specifically. But that's the standard definition. However, when we talk about calories in terms of human nutrition, we're actually really talking about kilocalories. We're really talking about that calorie unit on the 1,000 scale. Many of us, as dietitians, nutritional scientists, will use the shorthand and just say calorie. But when we're talking about human nutrition, we're really talking about kilocalories. In case you happen to notice, food labels are listed in kilocalories, and yet we're talking about calories. That's really what we're talking about. It's just a shorthand that we use. We know that 1 pound of fat is about the equivalent of 3,500 calories, kilocalories, if I'm going to be specific about things. Just a metric out there as you think about, we're going to be talking later on in the course about obesity, about hunger, about eating disorders, just so that you have that metric in your mind. And the common wisdom for those of you who might be wanting to lose some weight is just that we recommend that you do that gradually, very slowly, decrease your calorie intake very modestly. 500 calories a day should lead to about a pound a week weight loss, if you divide that by 7 days in the week. This is a table from the dietary guidelines, the 2010 dietary guidelines. I just want to point out from this slide specifically, I am going to be posting these slides on the Blackboard site, so don't worry about copying down all of these numbers. But I have highlighted the blue boxes here, give you the calorie range that we think you need to maintain your body weight. You can see that we separated by females and by males. I've put in the box I think most of you are in, the 19 to 30-year-old range. And you can see for women, we think that the calorie needs range anywhere from 1,800 calories a day to 2,400 calories a day, depending on how active you are. For men, it's 2,400 calories to 3,000 calories a day. I'm seeing a lot of you very intently reading the slides, so I don't want to move ahead too quickly. But again, you're going to have this information on Blackboard, and you have the URL for the entire dietary guidelines at the bottom if you want to look into this a little bit further. So I had mentioned that we talk about macronutrients. And if you remember from the reading for today, those are carbohydrates, proteins, fat. And I have alcohol in here because alcohol does contribute calories to our diet, although most of us would not consider it actually a nutrient because it's A, not required for health, actually detrimental to health in some cases. And so in that definition, it doesn't meet the nutrient definition. So the macronutrients are the only group that we're going to be talking about today of nutrients that actually contribute calories to the diet. As you can see, carbohydrate and proteins contribute about 4 calories per gram of the food item. Fats are a very concentrated source of calories and provide 9 calories per gram by weight. I'll let you all digest that thought just a minute. But the one thing that I do want to point out on this slide is that most foods are not just one of these macronutrient groups. Most foods contain a mixture of the macronutrients. For example, the banana that I have up here in a picture is mostly carbohydrate, as most fruits are, but there is some protein and there is some fat in bananas as well. So, while I am going to be talking a bit about the nutrient components of food, I want to keep drawing us out to thinking about the actual foods that you encounter in the day. Carbohydrates. Most of you probably know carbohydrates are our sugars, and we talk about simple versus complex carbohydrates. Alanna told me she was at a conference all day about carbohydrates and complex carbohydrates. When we talk about simple carbohydrates, we're really talking about actual saccharide or sugar molecules. Glucose, fructose, and galactose are the primary simple sugars. Maltose, sucrose, your table sugar, lactose, milk sugars, are a combination of those simple sugars. Complex carbohydrates, once again, are kind of building on those sugar building blocks and just getting to be more elaborate chains of those simple sugars, branching chains. And those are going to be glycogen, which is the way that our muscle and our liver stores excess sugars in the body, starches, and dietary fibers. Glucose, again, I'm going to be covering these things pretty quickly, but glucose is the primary nutrient for energy in the body. You can kind of think about it as the primary nutrient unit of energy that our body uses. Most of the disaccharides, the complex carbohydrates get metabolized down to a glucose unit. Following a meal, the glucose in your blood is taken up by the liver and redistributed into the circulation. It's first off going to be used to fuel your body, fuel your immediate needs for energy, the tissues, fueling your muscle, providing that energy. After that need has been satisfied, then any excess is going to go back into repleting your muscle stores of energy or your liver's store of energy in the form of glycogen. Once that compartment is repleted, and it's not a very large compartment, all of the rest of the sugar calories that you take in is converted to fat for long-term storage and sent out to the peripheral tissues and to your adipose tissue for long-term storage. In healthy individuals, most of us have our blood sugars are very, very tightly regulated. I think you all know that when your blood sugars are out of control, you have a condition called diabetes. That can either result, our bodies need the hormone insulin to be able to take sugar out of the bloodstream and deliver it to the tissues to be used. People who have diabetes either have a lack of insulin production, and that's type 1 diabetes. That's about 10% of diabetes cases. Or what's much more common is that people have what's called insulin resistance, where their cells, for whatever reason, don't recognize the insulin, and so their body isn't able to use the sugar that's in circulation. That's about 90% of the cases of diabetes in the country. A lot of that has to do with carrying excess weight, and so it's potentially modifiable for a lot of people. All right, moving on to our next macronutrient, proteins. The same way that I talked about sugars being the individual unit for carbohydrates, amino acids are the individual units for proteins. Proteins are essentially chains of amino acids. They play very important structural roles in the body. They're a building block of muscles, of cells, of skin, of collagen. We have proteins that are enzymes. We have proteins that are carrier proteins for fat-soluble compounds in the blood. We have, you name it, a protein is probably involved in a health process. So it's a very important category of nutrients. For those of you who are interested in genetics and some of the molecular biology issues, proteins obviously are the product of gene transcription. It's what our genes encode. It gets translated into proteins, and that's how our body does its cell signaling. Obviously, good dietary sources for proteins, meats, poultry, legumes. I hope you're all familiar with those terms, beans, nuts, and seeds. This is just a depiction. This is my own depiction, so I apologize for the crudeness. But of the basic amino acid structure. All amino acids have a nitrogen group, an amine group, and a carboxyl group. And then this R value here is just how the different amino acids differ. They're going to have different side chains that determine all the different types of amino acids. We have a category of amino acids that we call essential amino acids. And when we use the term essential in nutritional science, that usually means that it's something that our bodies cannot synthesize, that we have to get those nutrients from our or from some other source. And so we do know that there are certain amino acids that are essential, and I have a list here for you. We do know that there are many other amino acids that can either be synthesized from this or from other components in our diet, in our body. So we do have some essential amino acids. And then the last macronutrient I'm going to talk about is obviously fat. I hope you all aren't hungry when you come to class today, because I purposely put a lot of really yummy looking pictures in this talk. As I said earlier, fat is a really concentrated source of calories. It gives you the most calories per gram. We use it quite commonly when we're worried about people who have been losing weight, or in some situations for emergency feeding programs to try and make sure that people get a dense source of nutrients. Obviously, there's a lot of texture and flavor issues. It adds a great flavor, a silky texture to most foods. But it has physiologic importance, and it also has nutrient-specific importance. It's actually, there's been a craze for the last 20 or 30 years to encourage low-fat diets and try and get people to be as low on the fat intake as possible, again, because we've been very concerned about the obesity epidemic. But you actually need to have some fat in your diet. It is not compatible to health to completely eliminate all fats from your diet. As we'll talk about in a minute, there's a whole category of fat-soluble vitamins. And if you don't have fat in your diet, you do not have the ability to absorb these nutrients from your diet, and you will develop nutrient deficiencies. So it's very important that you get fat in your diet. We do know, I should have put this on the slide, fat is a very important component of all of our cells. Again, for those of you who are in molecular biology and some of the biological sciences, you know that all cell walls have a phospholipid bilayer. Any lipid word is the same thing as fat. So you need fat to support a lot of your just basic functions in your diet. We also used to think that adipose tissue was simply where we stored excess calories. We now know that adipose tissue is actually a metabolically active organ and is actually responsible for creating a lot of the what we call adipokines or cell signaling molecules, and even some of our hormones can be synthesized. Many of them have a cholesterol base and can be synthesized by adipose tissue. So again, there is a very important role for fat. It is not simply something that we just need to eliminate from our lives. There are some types of fats that are better than others. In general, we encourage you to try and avoid saturated fats, cholesterol, and trans fats in your diet. Because we know that those are highly associated with developing heart disease, and that you switch a little bit more to the unsaturated fats. So what do I mean by that? And I'm probably going to give you a little bit more information than you really want to know, but I want you to understand the underpinnings of what we're talking about here. And saturated versus unsaturated fats has to do with the actual model, the molecular models of each of the fat molecules and how many carbon double bonds it has, carbon-carbon double bonds. With saturated fats, they're completely saturated with hydrogen. They have no carbon-carbon double bonds, which I've depicted up here, again, in my crude depiction here. You're going to find those mostly in, they're going to be solids at room temperature, which is one clue that you're dealing with something that's primarily a saturated fat. And you're going to find them primarily in dairy products, in animal fats. But once you start to get into the types of fats that have at least one double bond, you're going to see that they're going to be liquids at room temperature. So monounsaturated fats obviously have one carbon-carbon double bond. You're going to find those primarily in olive oils, peanut oils, many of the cooking oils that we might use, canola oil, nuts, avocados, olives. Moving on that chain, as you start to get more and more carbon-carbon double bonds in the fat molecule, we talk about those as being polyunsaturated. Contain at least two double bonds, if not more than that. Again, a liquid at room temperature. Again, many of them are oils that we would cook with. Fish tend to be a good source of polyunsaturated fatty acids. I hope one of the things that you're seeing with the dietary sources is that, again, going back to what I had said earlier, foods provide, a single food can provide many different nutrient categories. And when I'm listing the dietary sources here, I don't want to give you the impression that they're the only dietary sources. I'm listing these primarily as foods that tend to have higher levels of these nutrients than other foods. There are many, I don't have room in the slide presentation to list all of the nutrients that meet this definition. So within the category of polyunsaturated fats, I'm sure you all have heard of omega-3 and omega-6 fatty acids. I think this is where I hear a lot of terminology not being used appropriately, even from journalists and from people in the media. A lot of times people will just talk about omega fatty acids. Well, I want you guys to be in the know and know that there's very special types of omega-3 fatty acids and understand what we mean when we talk about them. The number after the omega has to do with where that first double bond occurs. And so in the long string of a fatty acid, omega-3 fatty acids have the double bond at the third carbon closest to the carbon end of the chain. Those obviously are really important. You probably heard all of the good publicity around omega-3 fatty acids and how we all should be getting them. Good dietary sources are from fish oils, and various different types of seeds. Some of these seeds are more commonly consumed in other countries and not here, although some of them are catching on, especially flaxseed and flax oil. Omega-3 fatty acids we know are very good at the hormones and the cell signaling messengers that they create tend to create less inflammation in the body. So you might hear that they're the anti-inflammatory nutrient. And there is science to support that. Omega-3 fatty acids, also a very good polyunsaturated fatty acid. The first double bond occurs at the sixth carbon from the carbon end of the chain. These tend to be a little bit more inflammatory. We want to have people have a ratio of omega-3 fatty acids, have omega-6 to omega-3 fatty acid ratio that's maybe about 5 to 1. Most Americans, I don't know if you're going to talk about this, are closer to like 10 to 15 to 1. As Americans, our diet tends to be a little bit more heavily on the omega-6 fatty acid side than on the omega-3 fatty acid side. And it probably is better for us to shift a little bit to having some more omega-3 fatty acids in the diet. Trans fatty acids, I'm sure that you all have heard this term before. This is a fat molecule in which you'll notice that there's a double bond there. Although it changes the conformation of the molecule in that the molecule becomes a little bit more rigid. Having the hydrocarbons across from each other, which is what we mean by trans. You saw previously I had them on the same side. That would be a cis fatty acid being on the same side. And we know from some of our epidemiologic studies that trans fatty acids are associated with higher risk of cardiovascular disease. So that's why we're concerned about it. That's why it has gotten a reputation for being bad. In most cases, where Americans encounter this the most is in commercially prepared products where they've purposely induced hydrogenation in order to change the texture of the fat products. So think about margarines. Sometimes it's used in peanut butters as well to give it more body. Although it is possible to have naturally occurring trans fatty acids as fats start to go bad. This is why you don't want to go to Costco and buy the big bucket of some fat for cooking and use it for several years. As the fats start to go bad, you can naturally have some of these trans fats occurring. So we don't want you to have a lot of trans fats in your diet, so buy your oils in small amounts. Dietary sources, obviously, I already mentioned margarine, some commercially prepared peanut butters. Many of the manufacturers are now trying to change their processes to decrease the amount of trans fats. So you'll see many that are labeled trans fats free. So just carefully check the products. Cholesterol. I had mentioned earlier, cholesterol is sort of the basic structure of many of our hormones. Many of our hormones are based off of this type of fat. Actually synthesized within the body. So where we're going to get cholesterol in our diet is mostly from animal sources. Egg yolks, organ meats, whole fat dairy products, red meats. Even if we do know that cholesterol levels in general are a risk factor for developing heart disease, but it's not an absolute. We also know that our own bodies synthesize cholesterol in the liver. So even if you were to completely eliminate cholesterol in your diet, we would still be able to draw your blood and detect some cholesterol in your body. It's that important of a molecule. Our body does have a way of producing it if you need it. As I said, it's a component for some of the steroid hormones. Actually, vitamin D is a cholesterol derivative. And it's also a very important component of our cell membranes, give our cell membranes structure. So again, even though it is something that we would encourage people not to get too much of, it is something that your body needs. All right, so now I'm going to move on to micronutrients. And our two categories of micronutrients are the vitamins and the minerals. These are very important molecules within the body, but they don't contribute calories to our diet. That's one of the distinctions and one of the ways that you can think about this. Vitamins are essential organic nutrients. And remember, I had told you that when we use the word essential in nutritional science, that means we have to get it from the diet. It means that it's not something that our body can produce. That being said, there's a few misnomers, and I'll point those out when we get to it. One of the things that I do want to tell you about vitamins, and I think that it sort of sets the stage to help you understand a little bit more, all of the vitamins that we know and we think about as nutritional scientists were all discovered within the last 100 years. This is relatively new knowledge in the field of nutritional science. And the other thing to think about with this is the nutritional scientists who were discovering these vitamins and their role in the body actually didn't care very much at all about human nutrition. They were all based in agricultural programs and much more concerned about keeping their cows healthy, their chickens healthy. So we have just really benefited from what they've learned about animal science and then translated that over to humans. It really wasn't, we as nutritional scientists did care about solving human nutrient deficiencies, but that was a rather much later development in terms of nutritional science. So just to kind of give you a point of reference and a way to think about this. Minerals, which we'll talk about as well, are inorganic elements that our body needs in small amounts for health, and I'll show you some of those details in just a minute. So I'm going to give you some tables here of some of the vitamins that we have identified. I'm not going to go through this in detail, but I want to point out that these vitamins play a lot of different roles in the body. We know, as you can see from the last column, a lot of the reason that we went after understanding these a little bit more was to solve problems, to solve nutrient deficiencies. We know quite a bit about what happens when you don't have these nutrients. We're starting to understand a little bit more about what happens when you have too much of those nutrients, which is kind of a new phenomenon. I know Alanna's going to be talking a little bit about both sides of that question. So I want to impress upon you as well, yes, you need these, and you need these to prevent nutrient deficiencies. We don't know that you need lots of these. They are micronutrients, and as you can see, we have the amounts here from the dietary recommended intakes for each one of these nutrients. I'll just quickly point out that the nutritional scientists started assigning letters in alphabetical order to these. And as you can see, it doesn't just go A, B, C, D, and E, F, and G. We don't have an F and a G or any of those types of things for a reason. We thought they thought they were on to a naming scheme, and then as we started to study these a little bit deeper, we realized, well, B vitamins aren't just one compound, it's actually a whole family of different compounds. So we have a number of different molecules in that one. For many of these, we also have alternate names because they were named something else before we realized they were a vitamin. So here is the other group. I wanted to point out that vitamin D is actually the misnomer here. We actually have the ability to synthesize vitamin D. Does anybody know how that happens? Sunlight on our skin can release the cholesterol in our skin and allow it to start into the pathway of vitamin D production. So again, that was we discovered that fact after it had already been named vitamin D. So that is the one misnomer in terms of being vital amine. I had mentioned earlier that we need dietary fat in our diet, and I wanted to point out this is why. We know that some of the vitamins are water soluble, meaning that you can pretty much absorb them. They can circulate in your blood without too much difficulty. Vitamins A, D, E, and K are fat soluble. Again, these are the vitamins that you need some fat in your diet to be able to really absorb and utilize. And these are the vitamins that actually need carrier proteins to be able to be soluble in your blood to be carried to the tissues where they do their work. Again, I'm just going to point out the major minerals here as well. I think most of you are familiar with many of these and the importance of having them. Obviously, we want everyone to get plenty of dietary calcium so that they can maintain good bone density. One of the nutrients, and I'm fairly certain Alanna is going to talk about sodium in a minute, is actually one where very few Americans have a hard time meeting this guideline. In fact, most of us have way too much sodium, and that's actually one where we're encouraging people to eat less of. And again, what I want to point out here is that for each one of these minerals, for the vitamins, they play really important and diverse roles in the body. And you really need the full complement of them. To focus on any one of them out of balance with the others can have health implications, and you really do need the full complement for health. And you really do need to be eating a variety of different good food sources in order to meet your nutritional needs. Any diet that is extremely restrictive to one food category or without one food category could lead to nutrient deficiencies. And there's a reason that we like so many different foods. We really do need all those nutrients. Public health nutritionist, I can't help but brag a little bit. Some of our biggest successes in the field of public health have been actually recognizing these nutrient deficiencies and resolving some of these problems for the entire population. Adding iodine to salt was one of the first food fortification programs nationally, and was actually very instrumental in reducing what's called goiter. Does anybody know what that is? Good, I'm glad you don't know what it is because we've eliminated it from our, it isn't a problem anymore, but it's a swelling of the thyroid gland. And we all get plenty of dietary sodium, and it just isn't a problem anymore because of most of us consuming iodized salt. We now, for the most part, get enough iodine in the diet. Vitamin D in the late 1930s. I think all of you have had vitamin D milk. In fact, I used to have a lot of patients when I was working as a dietitian who thought that was the name of milk, vitamin D milk. But it's actually something that the dairies are required to add to the milk at the dairy before sending it out in order to prevent rickets. If you don't have enough vitamin D, or you might not absorb enough calcium in your diet, there was a real problem with rickets. And now, how many of you have seen somebody with rickets? Good. Nobody has seen anyone with rickets. You see it a little bit more in some developing countries, but not here because we have this food fortification program. I just want to point out there's been a few other things that are added, but for the most part, we didn't add a whole lot until 1998, where folic acid was added to the food supply in enriched grain products to decrease the risk of birth defects. So, as much as it sounds like we nutritional scientists have a handle on everything there is to know about nutrition, we don't. We're only just starting, and I hope the story about vitamins gives you a little perspective that this is still an evolving science. This is actually still considered a very young science. We know that there are thousands of other bioactive food components in foods that are naturally occurring that we have yet to even identify. And I have here a definition from the Federal Register, and you'll notice the date is from 2004. This was only 10 years ago. The federal government was asking us, how do we define what a bioactive food component is? So we are still, as nutritional scientists, meeting, arguing about definitions, about how we categorize things, and still identifying new compounds. So a very young field, you're going to be hearing more and more about these nutrients. But we know that things like lycopene, I can never say that, epigallocatechin gallate, ACGC, EGCG, I always get that wrong too, isoflavones, resveratrol. There are many others that I could have listed here that are important to health, that play important roles in our body's health that we don't fully understand. We're just starting to identify all the different roles that they play in the body. More to come on that issue. I don't want to leave out water, and a lot of people don't think of water as a nutrient. I do. It's really an important component of what our needs for health. It's vital, allows for transport of nutrients to cells. It allows our body to eliminate waste through our circulatory system. It's a component of absolutely every cell in the body. So we do need water. We have the recommendation from the dietary reference intakes that men need about 3 to 4 liters a day, which is about 15 cups of fluid a day. Women need about 3 liters a day for optimal health. Now, when we say that, it doesn't need to be just water. And in fact, we'd encourage it not to be entirely all water because it can cause some problems if you're not getting other minerals along with that. But any type of fluids meets that 15 cup a day. The 3 liters a day is about 12 cups a day for the women. I want to take just a minute to talk about dietary supplements. I want to remind everyone that dietary supplements were originally designed to alleviate nutrient deficiencies. That was really the goal. When we started to identify vitamins and minerals, and we started to realize that, oh, those were the factors that prevent these nutrient deficiency diseases, dietary supplements were designed to be used medically to treat those issues. Now we have a situation where dietary supplements are a huge business, and there's a lot of different supplements on the market. I want to put out the concept for you to think about that dietary supplements are only going to be as good as what we nutritional scientists have identified is important to put in there. And if you remember, I just said, we don't know everything yet. We are just starting to think about all of the nutrients that we need, that come from foods that we need for health. So we don't have the total picture yet. There's a lot of science fiction talk about the day that we get to taking all of our nutritional needs in a single pill. I can tell you we are nowhere near that. And so foods are still very, very important. I actually don't know if there's any nutritional scientists seriously trying to do that. We know that there's so many other reasons to eat food. So again, you're always better off if you make sure that you're eating a well-balanced diet, that you're eating a variety of foods a day, that you're getting 5 to 9 servings of fruits and vegetables every day so you get that full complement of nutrients, even the ones we don't know about yet. My own area of research, I'll just spend a minute talking about it. We know food provides a lot of nutrients. Foods are really important. We're also starting to appreciate there's a lot of non-nutritive things that come along with the food and water supply. We know that it's a way that we get foodborne illnesses. We can get bacteria, microbes on our food that can give us adverse health outcomes. We're starting to appreciate there's even some environmental toxicant exposures. Even this week, there's been some reports about concern about some of the caramel coloring in soft drinks. I'm seeing some heads nodding. Good, you guys are reading the literature. As early as we are in the field of nutritional science, this is very early days for understanding all of these different components. But I think that you're going to be hearing a little bit more about the non-nutritive aspects of food as well. We also know that sometimes food and nutrients and toxicants can interact. We know that arsenic contamination in water supplies is common in certain parts of the world. We know Bangladesh, parts of Chile, parts of the northern United States, the New England states, and the northern Midwest have a lot of arsenic in the ground and in the rock formations there. That gets into the water supply. You can have some problems health-related of having excess arsenic intake from drinking the water in those areas. But we also know that the vitamin folate can provide methyl groups to help our bodies eliminate that arsenic. So where that arsenic contamination is a major public health issue in Bangladesh and in parts of Chile, it's not a major public health issue here in the United States because of our food fortification program. Most Americans have fairly good folate intake, and I know Alanna's going to talk about that. And so it isn't quite the public health epidemic for us as it is in some of these developing countries. And we are just starting to appreciate how some of those things interact, and you're going to be hearing more about that as time goes on. I just want to leave you with an overview of, I talked about the dietary guidelines for Americans being developed right now. This is a synthesis of our leading experts in the field of nutritional science and evaluating the current science that we have available. They're able to synthesize it into these very succinct bullet points. Obviously, we're very concerned about the obesity epidemic, so it's very important to balance your calorie intake with your physical activity. That's how we burn our calories to try and maintain a healthy weight. We know that it's important to consume more of certain foods that provide all the nutrients we need: fruits and vegetables, whole grains, fat-free, low-fat dairy products, seafood, to get those omega-3 fatty acids. We also know it's important to try and consume less salt, less saturated and trans fats, cholesterols, added sugars, and refined grains. Anybody notice anything about this slide in these comments? Testing your knowledge and seeing how alert you were earlier when I mentioned this. It's subtle. It took me a while to kind of pick this out. You notice when we're talking about eating more of, I'm giving you actual foods, and when I'm telling you to eat fewer of, I'm telling you nutrients. Do you remember what I was talking earlier about the whole concept of nutritionism and reductionism? It's easier to find common grounds to talk about this. Some of the food sources for sodium, trans fats, are provided to us by some major food manufacturers in the country who would be very unhappy if we named their foods by name in the consume fewer of. And so it's a diplomatic thing. It's our, how we find common ground to be able to come forward. It's not untrue. This is our recommendations for you. On the flip side of that, I do want to say that, again, for every food item that you have, you're going to have a variety of different nutrients. And to single out any one food as being villainous and something that you shouldn't have would also truly be unfair. For some things, there are some nutritive value to it. But just to help you think a little bit more deeply about it. Again, you're going to have these slides on the Blackboard site, so I do want to leave you with just some reliable sources of nutrition information. There is a lot of nutrition information on the web. I would encourage you to think critically about what you're reading and think about the source of the nutrition information and where you're getting your information from. Hopefully some of the things that we've talked about today will help you think a little bit more deeply about the things that you're reading on the internet and in your readings. But again, I would encourage you to use some of these resources as reliable sources of information. So with that, I am going to move along. I know I, as usual, take a little bit more time than I should have, and I apologize for that. I want to go right away into introducing our next speaker, Alanna Moshfegh. She is a supervisory nutritionist with the Food Surveys Research Group at the Beltsville Human Nutrition Research Center, which is actually part of the USDA's Agricultural Research Service. Their group monitors and assesses food consumption and related behavior for the U.S. population, and that's what she's going to be talking about today. They conduct surveys and develop a lot of the resources that we as nutritional scientists use. The one comment that I want to make as she's coming up here is that we're also very proud of all of her ties to GW, being married to a GW alum and the parent of a current GW student. So I'm going to turn it over to you.
Thank you, Kim. I saw this class being offered last year because I'm always on the GW site and what's going on. And I thought, oh my gosh. I mean, I was just enamored with it, reading about it. And so when I got Kim's invitation, you know, I ran to my husband, guess what, guess what? I'm going to get to go to the World on a Plate class and tell them about what I do. I said, could life get any better? I may be able to retire now after being able to do this. And so I'm going to talk about the state of the American diet. My husband always tells me, well, it's easy to talk about that. In 2 words, we eat too much, or too much. That's the state of the American diet. There's a little more to it than that. So I'm going to start with first giving you an overview of what your federal government does for you in terms of our national surveillance program to look at the health and nutritional status of Americans. The dietary status, or the portion of this national survey, we call What We Eat in America. Then I'm going to move to give you just a sampling of what some of the results are to give you an insight into what is the current state of the American diet. So let's get started with the National Surveillance Program of Health that the federal government does. It's called the National Health and Nutrition Examination Survey. Its purpose is to, obviously, assess how is the health of the population and how's the nutritional status of the population. The main survey is conducted every year, and it's done by the Department of Health and Human Services. Now, I work for the Department of Agriculture. So they work with us, and we do their dietary intake portion within the Haines survey, and that's what I'll spend most of my time explaining to you. But I want to give you some of the basics about NHANES. It's a survey that samples 5,000 Americans from across the country every year. It's been continuous since 1999. Prior to that, it was done every few years. We draw a new sample of individuals every 5 years. We go to 15 geographic sites and collect data on this sample of 5,000 individuals. The data, all the data that's collected, is released every 2 years. So every 2 years there's data on 10,000 Americans and what does their health look like and what does their dietary status look like. The content within NHANES is so rich in terms of looking at various aspects of health. And this slide gives you just some of the major components that are tested within the NHANES sample through questionnaires, through blood draws, through urine collections, through saliva collections, through a number of medical examinations done on the sample. But today, we're going to focus on dietary intake. So as I said, we call the survey What We Eat in America because you're supposed to have a topic, a title of a topic, that tells people what it is the information is about. So for each of these 5,000 individuals, we collect what we call 2 24-hour dietary recalls. A dietary recall is a method for determining everything an individual ate and drank over the past 24 hours. We do that through trained interviewers who sit across a table from the respondents and ask them in excruciating detail, I think, everything they ate and drank over that past day. We do 2 recalls, as I said. The first one is done in person. The second one is done by telephone about 3 to 10 days after the first one's done. The reason for the distance of at least 3 days is because if people have made a big pot of chili or something and they eat it over a period of days, from previous research we've done, we know if we have a separation of at least 3 days, we're getting a much broader representation of the food and beverages that have been consumed. We conduct these recalls across all 7 days of the week. And we do that because people eat different on weekdays versus the weekend. And the weekend, when you're in the dietary survey business, kind of starts on a Friday, because when you look across the data, intakes are a little richer in terms of calories on Friday and Saturday. Then by Sunday, we see the intake going down a bit and looking more like Monday through Thursday when you're looking across the data. The method we use for this 24-hour recall, we call the automated multiple pass method. And it goes through a series of these 5 steps that you see graphically pictured here on this slide. And so a nutritionist goes through the computer program of these 5 steps, over 30,000 different questions and response options, asking people what they ate and drank yesterday. We start first with what we call a quick list. Tell us everything you ate and drank yesterday. We're not interested too much in the exact details of the food or beverage, but we want everything, including water. Now, how good a respondent would you be? Think about what you ate and drank yesterday. Then we start with our second step, which we call the forgotten foods list. We prompt people for 9 categories of foods and beverages that we know from the years we've done the survey that we typically forget. We start first with beverages, because we know that's the category people typically forget to tell us about. So we prompt for these types of forgotten foods. Then we go to step 3. For every food and beverage, including water, that they told us, we ask, about what time did you start to eat that food, and what would you call the eating occasion? Was it your breakfast, lunch, a snack, a drink break, etc.? Then we go to what we call the detail cycle, which takes the bulk of the time of the interview, which takes between 20 to 30 minutes. And for every food and beverage they told us, we ask them exact details so we can find out if they said it was milk. Well, was it skim milk? Was it flavored milk? How much milk did you consume? Did you add anything to the milk? Did you add Hershey's syrup, which can add calories and sugar to the product? We also ask, where did you get the food? As well as a number of other questions during that detail cycle that gives us further information about all those foods and beverages, including the amount. And then the last step is, was there anything else you forgot to tell us? As you have remembered things as you go through this detail of a 24-hour dietary recall. This is what the mobile examination center looks like, which goes to these 15 sites across the country. It's 4 tractor trailers, travel across the country, go to a site. I think this picture is taken in a parking lot of a hotel. We connect them together, and respondents go in and have a full medical examination done, as well as their dietary recall. So this is a picture inside that mobile exam center of the real estate that we get for doing the dietary recall. The woman here obviously is the dietary interviewer, and you can see the different food models that are available to the man, the respondent, for helping to estimate their portion size. Unless you're really interested in what you eat, like nutritionists are, so we have a really good idea of everything that we've consumed. There's a lot of people that eating is just maybe not that important to them, so the details of what we're asking about for these foods and beverages can really be a challenge for them. You're probably thinking, well, why are you doing an interview where you sit across a table? There's all these food apps. I can get it off my smartphone. The kind of detail we need for this type of data so far doesn't lend itself to an application on a smartphone. There's just not enough places for the questions. The food supply is changing so rapidly that we have to update the AMPM, the instrument we use, every year to keep up to date with the food supply, as well as then you have the issue of people perhaps not responding to you if you're wanting them to give you this kind of information. So a great deal of attention is given to be sure the people that are drawn into the sample at each of these 15 sites fulfill the requirements of coming to the mobile exam center, having not only the dietary interview done, but all the other measurements that they have. So for the in-person interview, we interview in this mobile exam center. Respondents have a number of components that they go through, and they can be in any order with one exception. And that is for when they have their body weight taken. That is always done after the dietary interview is done, so there's no bias of them perhaps not giving us the full information. We make an appointment for the telephone interview at that point and then call them based on when the appointment is made. And we send home with them food measurement aids to help them in estimating their portion size. So this next graphic shows you the day 2 telephone interview and what the models are that we give them. This is a graphic of the USDA food model booklet and some of the pictures that sit inside of that booklet to help people estimate their portion size. When we evaluate the data, though, we only get about a third of the calories, and you all know what calories are now, a third of the calories for the day from people estimating their portion size from the food model booklet, because Americans eat so many products that are already standardized for them in prepackaged foods, McDonald's, Big Mac, etc. And in our databases at USDA, we have the exact portion sizes for those things. And so we don't have to burden the subjects with, well, about how many of the French fries did you have if you had a medium order of French fries? We know exactly how many grams of French fries. We just ask, did you eat the whole thing? And what did you put on those French fries? Because ketchup is a very popular food, contributes a lot of sodium, contributes a lot of added sugars, but also contributes lycopene. Okay, now so enough about NHANES and how we collect this data. Let's move to now, what does the data tell us? So we've heard a bit about the dietary guidelines for Americans, the current version 2010 that's out there. And with this version of the guidelines, there was a real effort by the government to try to make the messages a bit simpler and easier for broad base of Americans to understand. And so that's how I'm going to try to show you what some of the data looks like from these messages. So let's first start with balancing calories. We heard about that a little bit earlier. Enjoy your food, but eat less. And avoid oversized portions. So what does our data tell us in terms of these two kinds of messages? Well, we know obesity in the United States is a tremendous problem. And here, this is data up through 2009-10 looking at obesity rates among children and adolescents. So just look at 2 to 5-year-olds. What is it, about 11% are considered obese, and 12 to 19 and 6 to 11, it's up to nearly just under 20% of these very, very young children are considered obese. And of course, for adults, it's about 2/3 of the adult population that are overweight, and many of them obese, and even at severe grading levels of obesity. So what does energy intakes look like? Because this is reflecting of all of the foods and beverages we've taken in over time. So this shows you in the late 70s, mean intakes. Now this is across the whole population on average. So this is intakes of 2-year-olds as well as 25-year-old athletes as well as 50-year-old individuals. So it's averaged across the whole sample in these surveys. Calories were just under 1,900 on average. By the mid to end of 1990s, they had gone up about 150 calories. Today, they have increased since the mid-1990s by about 50 calories. Now, the method of how we collect this dietary data over this long span of time has improved. I think we're doing a better job of getting this data. But as you can see, the caloric level increase is tracking with the obesity level. Of course, we know men consume more than women, and the dark green are males 20 plus, and the lighter green are females 20 plus. And these numbers don't look too different on average than the numbers that Kim showed you for recommendations in terms of what dietary intakes for calories should be. What about who's reporting different meals and snacks? We get this kind of information off of the survey. So you can see almost all Americans, 85% of them, have breakfast in the morning. Almost everyone, even more so, 96% of Americans report at least one or more snack. Today, about 2/3 of us have what I call the three squares: breakfast, lunch, and dinner. 1/3 of us, though, are only reporting 2 of these types of meals. 5% are only reporting 1. The next few slides are going to show you percent of energy or calories coming from these 3 categories. First, meals or snacks. We become a country of snackers. We get 1/4 of our day's intake in terms of energy from snacks. That's twice what we were getting from snacks in the late 1970s. And look at this graphic to show you the change that's gone on in the number of snacks. In the late 70s, most people were having no snacks or no more than 1 to 2 snacks per day. We were eating 3 basic meals: breakfast, lunch, and dinner. But today, from the 9-10 data, you can see the majority of Americans are having at least 3 to more than 5 snacks per day. So we've become a country that eats frequently throughout the day. Now, what's defined as a snack? This is self-reported by the respondent, themselves calling it a snack. When we look at the data as to what constitutes a snack, it looks like, in my mind as a nutritionist, as almost a complete meal. Food at home and away from home. Today, 1/3 of our calories come from food choices away from home. This is nearly twice that of the late 1970s. So again, you're seeing these shifts of what is going on in terms of the choices that we're making and where we're making those choices. The last on this is the contribution that beverages make to our total day's intake. 20% of our energy comes from beverages, so they play a very important role in terms of what our total diet looks like. This isn't much different than the late 1970s, where 16% of our calories came from beverages. Now let's move to the next broad-based message: foods to increase. Make half your plate or your bag, or just how you are eating your foods, fruits and vegetables. A strong push for increasing the amounts of fruits and vegetables in our diet, as well as switch to fat-free or low-fat milk, no more than low-fat being 1% of fat in the meat. So what does the diet look like in terms of that? This graphic shows you the percent reporting these various categories of foods. In the survey, we have a database of over 8,000 foods and beverages. So you can't report every single one of those. You have to group them together. So you can see here, the dark green is 2009-10, the percent who are reporting grains, protein foods, snacks and sweets, mixed dishes, vegetables and fruits, compared to 2001 and 2. So about a 10-year difference. And you can see we're not changing too much, other than vegetables are decreasing, which is not a good sign, but fruits are increasing a bit. So it's supposed to be half of our plate being fruits and vegetables. We have a ways to go. What are the top 5 vegetables and fruits that were reported in 9/10? Potatoes by far make up the predominance of vegetables in this country, driven by French fries. Lettuce, of course, then tomatoes, etc. For fruits, it's bananas first and then apples, followed by the others that you can see on the slide. So in terms of variety of foods, it's an age-old message: have a well-rounded variety in your diet. We have a ways to go from that standpoint as well. This slide shows you the change in the daily number of fruits and vegetables. So in the late 70s, on average, people were reporting 2.6 fruits and vegetables on average. It's a drop. Today, it's just a little under 2. A fourth of Americans in this country on any given day report no fruit or vegetable or juice. Now by that I mean where they've made a conscious choice of having a vegetable. You might get a little vegetable, a slice of tomato on your burger that you get. I'm not talking about that choice of vegetable. I'm talking about, I'm going to have a serving of carrots. Another fourth report only 1. And 19% of Americans report eating French fries on any given day. That's 1 out of 5 of us. So just think of how many are sitting in this room. 1 out of 5 of us are having French fries. Probably driven by that drive-through quick convenience, as well as the cost of the convenience. It's inexpensive to eat at fast food restaurants. This shows you the same kind of data for beverages. We're supposed to be moving towards consuming low-fat milk, and you can see we're decreasing in percent report of individuals reporting milk. But the other good news is we're also decreasing in the percent reporting sweetened beverages. Those are primarily driven by soft drinks, but also other types of fruit juice drinks that, of course, are sweetened. We're to increase our consumption of low-fat milk. On average, almost half of Americans report no milk at all. So this is milk added to cereals. This is any type of milk. You can see that the percent reporting skim milk is 10%, has not increased whatsoever. A little bit in terms of the percent who are reporting 1% low-fat milk. So we've got a long way to go in terms of meeting dietary recommendations. This is the same presentation in terms of the graphic, but this looks at these same categories of food and the percent of mean daily calories or energy that are coming from these foods. So you can see mixed dishes, which are things that include a protein and a starch or a carbohydrate, etc., account for 20% of our calories. Snacks and sweets are the second contributor of calories, along with protein foods, accounting for 16%. Mixed dishes here include meat, poultry, seafood, and grain-based, with a combination at 8%. 4% of our energy comes from pizza, 3% from Mexican or Asian type dishes, 3% from sandwiches, soups, etc. But this slide that shows the change that has gone on in pizza consumption. 14% of Americans report eating pizza on any given day. And for those that do have pizza, we pulled out those 14% and looked at what was the contribution of pizza to their total daily energy intake? It accounts for 25% of their energy intake. And you can see here the percent of reports of pizza from the late 70s to 2007 and 8. Of course, it's being driven by very, very young kids, the 2 to 19-year-olds. But I assume many of you in this audience are consuming quite a bit of pizza. And in my family, we eat a lot of pizza as well, because you can call up on the phone and it's there in 30 minutes, and I don't have to lift a finger in the kitchen. Okay, snacks and sweets, what accounts for those? Cakes, cookies, donuts account for half of the calories in the snacks and sweets, followed by the other things that you can see on the slide. Protein foods, poultry is the major source of calories from protein foods. It has surpassed beef in this country. Now let's go to the last broad message, foods to reduce. The first focus is on looking at the sodium content across foods and choosing those that have lower content of sodium, and to drink water instead of these sugary drinks. So let's take a look at sodium intakes in this country. There's two red bars here, 2,300 milligrams of sodium and 1,500 milligrams. The 2,300 milligrams of sodium is generally the recommendation for the entire population. The 1,500 is for people who have hypertension, African Americans, and older adults in general. You can see across all age groups, we are having difficulty meeting having diets that do not exceed 2,300 milligrams of sodium. If we look at then sweetened beverages, which we're trying to replace with more water, they contribute 6% of the calories in our diet, greater than the contribution of calories from milk, which isn't surprising as you look at the data. 2/3 of those calories come from soft drinks. Another third comes from fruit and sports drinks and energy drinks. And look at this data in terms of the mean amount of soft drinks per report. 21 ounces when people report they have soft drinks. This is the average intake. Today, just a little under half of Americans report having at least one or more soft drinks per day. This slide was what I wanted to show in relation to nutrient intake, and I think I would just have one, or maybe there's one other one. This is the percent of Americans who have dietary intakes that are below their estimated average requirement. This is a standard of the nutrient that they are supposed to have based on their age and gender, and for some categories, their lifestyle characteristics. You can see for vitamin D and vitamin E, most Americans do not meet their recommendation for that particular nutrient. For magnesium, calcium, vitamin A, and vitamin C, between 1/3 and nearly half of Americans fall below their recommendation for that nutrient. There's a different standard if you're a smoker. You have a higher requirement for vitamin C. 81% of smokers are not meeting their recommendation for vitamin C. For zinc, B6, and folate, we're not doing too bad. And for these remainder nutrients, less than 6% are below their recommendation for the nutrient. This slide looks at the percent of Americans that are reporting using a dietary supplement. Now, the data that I just showed earlier about nutrient intakes was only nutrients from food, beverages, and water. But on average, about 1/3 of Americans are taking a dietary supplement. The nutrient that's impacted the most from the dietary supplements that people are taking is calcium. So that's one of the supplements, whether it be in a single supplement form or a multi-vitamin mineral form, is contributing the most from dietary supplements. This is our website for where you can get much, much more data than what I've tried to cram into the time that I've had. It's a long address, but I think I checked it yesterday. If you Google what we eat in America, you will find us without having to scroll down. Thank you for your time. We're located out in Beltsville, Maryland. If any of you are interested in going into nutrition and want to come out and tour our facility, we welcome you to come. We can tell you what nutritionists do. So thank you very much.